Hello everyone and welcome to this another episode of 3D Prototyping in Unity. My name is Kisanis. In the last episode, we actually went through and physically set up our character. We created the asset, the character itself. We enabled this character to be able to be affected by the physics engine by adding a rigid body. We added a capsule collider to define this character's space in the physical world and allow that character to interact with other objects that have colliders. We added a weapon to his hand as well, which doesn't really do anything right now, but later on it's going to. That's what we did last episode. Now, right now, this character can't do anything at all. He falls, he doesn't move, he just stands there absolutely still. In today's episode, I'd like to change that. I'd like to create our animation maps, and I would like to define the code that is going to allow this character to run back and forth. All right? Sounds like a lot of work, and you know what? It's going to be. But let's get started. Okay guys, so we are going to start off very slowly with this episode. There's some coding involved, and I know that scares a lot of people, but don't worry, it's not going to be too difficult. We're going to first of all define the assets, the actual assets required in order to make this character move about. And we'll take a look at them very, very briefly, and then move on to the code that actually allows the movement to take place. Now, in last episode, we talked about this animator. Now, we talked about it very, very briefly. All we did is I just mentioned it in passing. In this episode, what I want to do is actually get this thing working. Unity uses something called mechanism to define, to allow the animator to define an animation state machine, basically, that allows us to move back and forth between different states of animation. If we take a look at the model itself, and we take a look at the animations we created in the last episode, those become the states of our state machine. And by defining a particular parameters that allow us to move from one state to the next, we can actually create animation in this character, the run, the walk, the jump, etc. Okay? The first thing we need to define is, I'm going to go to the animation. I have an animation directory here. And I'm going to create something called the animator controller. And you can either say create, and you can find animator controller in here, or you can right click and say create, and you can find animator controller in here, which is what I'm going to do. I'm going to rename it right away to player. I'll just call it player AC. Player AC, player animator controller. Now this player animator controller is what's going to allow us to actually build the state machine. I'm going to click on my soldier, and I'm going to fill in this controller where it currently says none. I'm going to fill in that place. I'm just going to drag it. I'm going to drop it, bam, right on there. So when I do so, player AC now comes into this place where it says controller. Great. I'm going to now, either if my animator is currently open, it's right there. If your animator is not open, then go Window, find your animator, click on it. It's going to pop up this window. Once you have your animator up, what we can do is we can take our animation states from our model, which was right here, and we can drag them and drop them into place in this actual state machine. Now I'm just going to take the player idle for now, and I'm going to drop it right here. It doesn't really matter where I put it. Right there, that's where I like it. The player idle. I grabbed the player idle and I put it in place. Now you can see that this player idle is orange, and it tells me the speed that this player idle is working at. If I take a look at this by clicking on it, it'll tell me that it's got a certain speed, etc., etc., etc. We'll take a look at that in a little more detail after. But what I do want to show you is what this does. When I hit play now, bam, it's only a very slight animation on it. It's a very slight idle, but you can see that my player is currently idling. All right. He's got a slight up and down movement, and that is his player idle. That is great. So, first things first, let's take a look at this. The player idle itself is right here. When I click on this individual state, I do have access to speed. If I change the speed, let's make this 2. I'll make it 2 for now, and I hit play now. The animation is going to work at twice the speed. All right, if I make it 0.1, it's going to work at 1/10 the speed. So you have the ability to come in here and actually change the the speed at which the animation is being created at. So if for some reason as an animator you've gone through and you've created everything, and afterwards you realize, whoa, I don't like the way everything is, I need it to go twice as fast, you don't have to go through and redo your animation in its entirety. Instead, you can change the speed. All right, that's one of the very, very first things I want to take a look at. Now, if I take a look at this actual map right here, it tells me that as I come in, I'm entering in along this transition path here, and I'm starting off my game by entering into the idle state. It's orange, all right? Orange means default. Now, let's say I add a second state. Let me put in my player run. Let's put in our player run right here for now. Our second state, you can see that the first state is orange and the second state is gray. I will never actually go into this player run. If I wanted to, right now, if I hit play again, we can see that my actual animation state is my idle. That's where I come into. If I wanted to instead, I could make this my default. Instead, I can just make him start off running. To do so, I'm just going to click on player run. I'm going to say set layer default state. All right, so you can see my entry has changed to player run. When I hit play now, bam, my character's running like crazy. He's running like crazy. All right, perfect. Now, I'm going to set this back to idle because obviously I want idle to be my default state. Now, as the animator, what I can do now is I can actually go through and I can create a map. I can start creating a map on how you get from one location to the next. I can say that we want to change states from idle to player run when a very particular thing happens. For now, I'm going to right-click on player idle. I'm going to say make transition. It's going to create this little line here, and I'm going to go across the player run. I'm going to click. All right, that's going to cause this connection to occur between player idle and player run. This is called a transition. I can transition from player idle to player run when something very particular happens, and we haven't discussed that yet. We haven't discussed what that very particular thing is. In fact, we're going to do that in code in a little bit. We can also say I can always go from player idle to player run, but right now I can't get out of player run. I will always stay in player run once I'm in there. Okay? If I want to go back again, well, actually right now, I shouldn't say that you cannot exit out of it right now because there's nothing that defines it. In fact, that's not true. If I take a look at this transition right here, there's something that's called the exit time. And the exit time will determine after a certain amount of time, the player will automatically go into this other state. So watch what happens if I hit play now. If I hit play right now, my player will idle for a little bit, and then he'll go into the run. Okay? Now, that is a kind of a random occurrence. Ultimately, we're not going to use that exit time. We're going to turn that off and make sure the player and himself or herself has control over when the character actually moves between states. But for now, I just wanted to show it to you. Now, right now, we can move in from the player idle into the run state, but we can never move back again. If I want to be able to go back, I have to create a transition in the other direction. To do so, I'm going to right-click on player run, make transition, and drag and drop onto player idle. Now you can see I've got an arrow going in both directions. All right, we can go from player idle to player run and from player run back to player idle. And this one here also has an exit time. So if I hit play now, watch what happens. I'll idle for a bit, I will run, and I'll go back to idle. And I'll idle for a bit, and I'll go back to run, and I'll idle for a bit. All right, so it's going to go back and forth with those exit times. Random occurrences we don't actually want to use has exit times. I'm going to turn them off right now. All right, bam, bam, and bam. Ultimately, as an animator, what I want to do is I want to tell the coder, whoever's coding this, I want to tell them, I want you to change from one state to the next, from your run to your walk, or sorry, from your idle to your run, based on a particular parameter. All right, and currently I don't have any parameters set up. If we look right over here in the corner, I've got something that says layers, and I've got something that says parameters. I'm going to click on parameters, okay? The parameters themselves, I have a various number of parameters that I can add, and these are all for the coder. They're not really for the animator. If I hit plus right here, it's going to allow me to add either a float, which is any number, an integer, which is any whole number, a bool, which is a true or a false, and a trigger, which is true and then immediately false again. All right? For my player to move from the idle to the run, I want this to occur whenever my player is holding down a particular button. And we'll discuss with those buttons later on, but for now, I know that that particular button is going to be a float value. Okay, so I'm going to add in here a float, a trigger float, or excuse me, a parameter float, and I'm going to call this one here speed. Okay, I'm going to say that whenever speed, I'm going to come into my transition, and I'm going to say whenever speed, I'm going to add in this here conditions, I'm going to add the plus sign, whenever speed is greater than 0.01, I want my player to transition into the run state. Okay, he's going from idle to run. I'm going to move this back all the way to here for now. And I'm going to say up in here on this arrow, whenever my player, I'm going to move this back to here just for now, whenever my player's speed changes from something greater than 0.01 to something less than 0.01, I want him to go back to his idle. That's probably not making a whole lot of sense right now. It'll make a lot more sense once we take a look at the code in just a second. All right, let's go take a look at the code. Okay, guys, I know for some of you, code is going to be a little bit scary, but I am telling you, don't worry, we're going to be perfectly fine. What we want to do is we want to go to our actual soldier, so we're clicking back on our soldier. I'm going to turn my scene back on. We're clicking back on our soldier, and what we want to do is we want to add a brand new component. So I'm going to go Add Component. At the very bottom, it's going to ask me to what I want to add, and I'm going to add a new script. Boom. And we are using C#, so make sure you've got C# selected. I'm going to add a brand new script that I'm going to call Player Controller. Player Controller. All right, this Player Controller script, and I'm going to double click on it to open it. The Player Controller script is going to be where we define all of our actual actions that are going to create our character motion, etc. It's going to open up MonoDevelop, unless you've got it set to Visual C, unless you've actually got it set up to Visual Studio. Mine's set up to MonoDevelop, which is what I prefer. So I've got MonoDevelop open here. When I open up in MonoDevelop, it opens up this brand new window. And we've got ourselves a couple of different things in here to start. We've got ourselves a start function and an update function. Above the start function, what we're going to do is we're going to add a number of parameters. Okay, there's a number of things that we're going to need in order to be able to make our character move properly. Movement variables. I'm going to call it that. Now, that's just a comment. Okay, so we have the option of either having a public or a private variable. All right. Public variables are available to you afterwards. They're available within the actual inspector over here as a variable that you can actually manipulate. Private ones are not. They are not shown at all. And we'll just discuss public and private for now, nothing else. So I'm going to add a public variable. So I want this to be able to be shown in the actual inspector afterwards. I'm going to add a public float, and this public float I'm going to call run speed. And run speed is going to be how quickly my character can run, the rate at which he can run at. Okay, yes, we've already defined how fast the character's leg move in the animation, but I want to define how far this character can run whenever you push a particular button. Okay, and I'm also going to define right now, I'm also going to define two private variables. You don't have to explicitly say private. Anytime you leave this private word out, then it's actually considered to be private right away. I'm going to define a rigid body, and this rigid body I'm going to call my RB. And what this is ultimately going to give me is it's going to give me a reference back to the rigid body we created on the soldier. We added a component called the rigid body to the soldier, and this is going to give me a reference to it, so I'll be able to manipulate the rigid body later on. All right. Secondly, I'm going to make a reference to an animator. We've already added an animator, and I want to be able to adjust the parameter that I created, the speed parameter. To do so, I'm going to need a reference to the animator. All right. So I'm going to create a variable called myAnim, which is a reference to the animator. And that's all I really need to start off with. All right, that's all I really need to define to begin with. What I want to do now in my start, down here in my start function, I want to define both the rigid body and the animator. I actually want to make a link to those two things. So I'm going to use a built-in function. First of all, I'm going to say my RB is equal to. I'm going to use the get component. So I'm going to start typing get, and I'm going to find get component. Now, get component, what this does is it will go on to the object where this script is located. Now, currently our script is located right here on the soldier, all right, on our player. It's going to go through that. It's going to look for a component, and it's going to look for a component of type rigid body in this case, all right, rigid body. And it's going to return the value or the reference to this rigid body to this variable myRB. I'm going to do exactly the same thing with my anim. I'm going to say is equal to get component. Get component. I'm going to use my. Let me make these bigger so maybe you guys can see it better. I know I'm doing this actually in full HD, so you guys should be able to see it pretty easily, but I'll make it slightly bigger. My anim get component, and this time I'm going to look for the animator. All right, and I'm going to put the animator into this variable. All right, so using the get component allows me to go on to the actual component here and find those individual things. Now that I've got them, we're in pretty darn good shape. All right, we're in pretty darn good shape. The next thing I want to do is I want to start taking a look to see if my actual player, the person playing the game, has given me any kind of input. All right, and by input I mean whether they've clicked the mouse buttons, whether they've clicked the keyboard, whether they've used the controller, whatever they're doing, joysticks, whatever they're using in order to be able to control this character. I'm setting this up to work on PC, and I'm expecting the people to have a mouse and a keyboard, and I'm going to base my movement on the fact that they're going to use the A and the D keys for left and right movement. All right. The first thing I want to do is I want to check to see if they have actually in any way pressed a button. All right. That's the first thing we're going to check, and we're going to do so by collecting the input and putting it into. Well, first thing I'm going to do is create a new function here, void, and this is called fixed update. All right, fixed update and update are both called periodically throughout the operation of this game. Update is called every single frame. Fixed update is called on a very fixed rate after any physics after the physics engine has been run. So it runs at a very particular time, and it's constant. Whereas update, as your frame rate changes, the number of frames you're going through changes, update may be called faster or slower. All right, so with physics objects, you want to do all of this work in fixed update. So what I want to do in fixed update is I want to check to see whether or not someone has actually pressed a button. Okay, and I'm going to store that in something I'm calling, it's going to be a float. I'm declaring a variable, a float here, and I'm going to call it move. Now, there's already a method of determining whether or not someone has pressed a button. Okay, Unity defines for you several different axes. They call them axes. Several different axes of input. So in this case, I'm going to be using move equal to input. All right, so it's already defined, input dot get axes. All right, and the get axes is going to go through and it's going to pull all the different axes you defined. And you know how in a game when you can actually define how your controller works, whether you're left-handed or right-handed, etc. Well, Unity's done that for you. All right, they've defined, and I'll show you how in 1 second. They've defined a number of different axes that will define different keys. So the one I want to use is horizontal. All right, so let's take a look at where I got that from. I'm just going to move this out of the way for a second. I'm going to put it over here. If I go to File, if I go to Edit and I go to Preferences, no, Project Settings, I'm lying, Input, what it's going to do is it's going to pop up this window over here in the inspector. And you'll see axes at the top. All right. If I open that up, you can see there are a number of different axes that are already defined. Horizontal, vertical, fire 1, fire 2, fire 3, jump, etc. Okay. Horizontal, if I open up this little arrow, horizontal is defined by the name horizontal. The navigation buttons are the left and the right, so that's the arrow keys, or alternatively the A and the D keys, and etc., etc., etc. All right, the vertical is also the up and down keys, but it's also the S and the W keys. So you can see that these are defining input from the keyboard or from various other objects, like you might take a look in here at Fire 1 is actually joystick button 0. There's a number of things that are already defined for you, all right? So in this case here, when I say take a look at axes, horizontal, it's automatically looking at the A and the D keys for me. The A key is a negative value and the D key is a positive value. So if the player presses down the D key and input.getAxes returns a value, it's going to return a value between 0 and 1. If the player presses the A key, then the get axis is going to return a value between -1 and 0. All right, 1 being the key is pressed all the way down, or -1 being the keys that were pressed all the way down, and 0 means the key is not being pressed at all. Now, the interesting thing about this is we can use this value, this move value, and we can put it into our animator right here for our speed variable. And remember we said if speed is greater than, let's go take a look again. If our speed, I'm going to make this a little smaller. If our speed is greater than 0.01, then the player is going to move from idle to run. And if our speed is less than 0.01, then we're going to move from run to idle. Now, let's go back and take a look at our code. In our code, and great, that's showing there. Let me just do this for a second, see if I can pop it up. In our code itself, we can actually go through and we can take that value, that move value, and place it into this parameter. Now, we're looking for a value greater than 0.01. And as I've already mentioned, move will have a value between -1 and 1. So we only want to take the absolute value of move. We want to make sure that the player is pushing the button, but we don't care what direction they're actually moving. Okay? So the first thing we're going to do, we're going to send this value, into our animator over here. And we already actually have access to our animator. We've given ourselves access to our animator through this right here, through my_anim. We've already defined my_anim right there, so we have complete access to the animator itself. Now, what we're going to do is we're going to take the value of move and we're going to send it over there. So, to do so, we're going to come here, we're going to say my_anim. All right, that gives us access to the actual animator. My_anim.setFloat, because that's exactly what we defined speed as. It was a float. And we're going to set the float to the value, or which float? We want to set speed, because you can have more than one float. That's the first parameter. So we want to set the value of speed to the absolute value of move. And we can actually find the absolute value of move using mathf.abs. So that's the absolute value of move. All right, close all my brackets off and do that. So with just this in place, just this simple code in place, it should allow us to switch back and forth between our two states. So I'm going to say File and I'm going to say Save. Now the player himself is not going to actually move yet. If I hit play, as long as I had no errors, when I hit my D key, I start running, and when I hit my A key, I start running. All right. Good. So we're switching between our animation very well. I'm going to tighten up the actual transitions a little bit here. Let's take a look at this one and this one. I'm going to transition a little faster, a little tighter, just like that. Okay, so with that in place, let's go back to our code. With that in place right now, we've got our actual character running, actual switching back and forth between the idle state and the run state. That's great. That's what we want to do to start off with. Now we want to actually start our player moving. So I'm going to add a couple of spaces in there. We actually have access to our rigid body as well. Right here, rigid body my_rb. And we've already defined out what it was in our get component. What I want to do is I want to set the velocity of my_rb, okay, to whatever move is times my actual run speed. So my_rb, which we've already defined, my_rb, which we've already defined above, and we're going to set the velocity, .velocity, and we're going to set the velocity equal to a new vector 3. So velocity of our rigid body has an x, y, and z component. All right. So that's why we're using our vector 3. Vector 3. All right, because it has an x, a y, and z component. We want our actual component to be fairly straightforward. We want our x component to be equal to move, which is the value we found right here. It'll be negative if we hit A and positive if we hit D. So if we hit A, it'll run backwards, and if we hit D, it'll run forwards. So move times, and we've defined a run speed right here. So move times run speed. Run speed is going to be our x value. Okay, that's our x value. Our y value currently, we don't want to change our y value at all. It's going to be whatever the velocity in the y currently was. So it's my RB, and my RB dot y. No, velocity y, sorry. Velocity dot y. So whatever it was in the y direction, we want to maintain that value in the y direction, all right? If it's falling by gravity, we want to keep falling by gravity. So we're not going to change that in any way. And lastly, we're going to have a z component, which we want to be 0. We don't want to have any motion along the z-axis, okay, of our character. And I'm going to close that off. All right, and I'm going to add my semicolon in place. So right now, whenever we start to push the button, our character should start moving at run speed. It should continue moving at run speed until we let go of the button. Okay, as soon as we let go of the button, move becomes 0, and our character is going to have a 0 times run speed. All right, let's save that again. File, save. Great. Okay, now let's go back here to our character for a minute. If we've done everything right, and we take a look at the soldier himself, we're going to see on the soldier right now we've got this additional location called our player controller script, and we have run speed in here as a public variable. And I want to give this a run speed, and I think the run speeds were 15. I can't really remember because it's been so long. Let me just check on my old one. What my old run speeds were. 1 second. My old run speeds were only 8. Whew, it had been going too fast. Anyway, it wouldn't have mattered. We can always change it. 8. All right, so with that in place, now whenever we push the button, so whenever I say play, as long as there are no issues, whenever I say play, my character will start idling, and whenever I hit the D button, my character will start running forward. And whenever I hit the A button, my character will run backwards. Now, he hasn't flipped around, and that is not cool. That's not cool. We want this character to actually flip around. This is a 2D side-scrolling platformer, and we want to be able to change our character's direction at will. All right? So the next part of the code we're going to have to add in there the ability to flip back and forth. Changing directions is fairly straightforward to do. Let me get my mono develop up here. It's fairly straightforward to do. Now, the first thing we're going to need is we're going to need a new variable. It's going to be a private bool that we're going to call facing right. All right, so whenever our character is facing right, this is going to be true. And whenever our character is facing left, facing right will be false. All right, we're going to start off right away by stating that our facing right is equal to true. When we start off the game, facing right is equal to true. We know that because we set up our character to be facing right to start off with. All right, so with that in place, facing right is going to start off as true. Now, there are two conditions that we will want to change facing right. All right, we'll want to flip our look in one of two situations. If, well, let's actually put them in right here right away. If if our move value is greater than 0, so that means that if it's greater than 0, that means that our player is pressing the D key. Because remember I told you move will be greater than 0. If D is pressed, it'll be between 0 and 1. So if our move value is greater than 0, and we use a double ampersand for conditional and we are not facing right. Facing right is not true. So, oops, is not facing right. This should be not facing right, sorry. Boop. Is not facing right. So if we are facing left and we've pressed the D key, then we actually want to flip. Now we haven't actually written our flip function yet. Now there's one other condition that we want to flip, and that is else if our move is less than 0, so now we're pressing the A key, so we're between -1 and 0. So if our A key is being pressed and we are facing right, so and we are facing right. If we are facing right, then we want to flip. All right, so this is basically saying if we press the D key and we're facing left, then turn the other way. If we are pressing the A key and we're facing right, then turn the other way. Now, we don't actually have a flip function set up yet, so let's do that right now. Flip, all we want it to do, you know, I struggle with this because this is not actually how you do it. And anytime I ever worked in a professional studio, whenever we flipped a character in a 2D side scroller like this, or excuse me, a 3D side scroller like this, we actually rotated the character completely around. And I wanted this to follow along with my 2D series. So I tried something new. Instead of actually flipping the entire character, what I did instead is I actually flipped the Z value. In the same way you do it in 2D. And what does that mean? If I take a look at my soldier right here, and I go up to my scale, and I take a look at my Z value right here, it's currently 1. If I set it to be -1, my character will face the other direction. All right? And this is rotating my entire thing. And this, ultimately, this is how I did it in my sample game, and I was kind of just building it as I went, and ultimately I ran into some problems, but I decided to leave it like this, and I decided to teach it like this, just because half of building a game is working through issues you face. All right. Anyway, it still works out perfectly fine. It just caused some complications later on. So basically, what I want to do, instead of rotating my character 90 degrees or 180 degrees, what I'm going to do is I'm going to simply flip my Z value from a negative to a positive or a positive to negative. Okay? Very, very easy to do. I'm going to start off by calling this a void function. Oops, one I, void function, and we're going to call it flip. Exactly the same thing we called it above. It's not going to take any parameters at all. It's not going to take any parameters at all. What it is going to do, simply, it's going to, if we are facing right, whatever facing right is, I want it to be equal to not facing right. So whatever it was before, invert it. That's what this line does. So if we were facing right, then we're not facing right. If we're not facing right, then we are facing right. That's all that line does, is invert our value of facing right. So we've actually flipped the value of facing right appropriately. The next thing I want to do is actually change that Z value, that scale of the Z value, okay? To do so is a little bit more complicated. We have to go through and we have to find the transform scale, first of all. So I'm going to set up a vector 3 that I'm going to call, it doesn't really matter what I call it. I'll call it the scale. All right, the scale is going to be equal to, and we're going to go into our transform node, and we're going to get the scale, local scale actually, local scale. All right, we're going to get the local scale value, okay? And the local scale value, let me move this down so you guys can see it better. The local scale value is these values right here, 1, 1, and 1, all right? I'm going to grab my local scale value. Afterwards, I'm going to take that local scale value, I'm going to take the scale, and I'm going to take the Z value, so the Z value of it, and I'm going to multiply that by -1. All right, so I can just say times equals -1. That's a short form of saying the scale is equal to the scale times -1. All right, that's just a short form of saying it. So basically, all I've done is I've multiplied -1. If it was 1, it becomes -1. If it was -1, the two negatives become a positive, so it becomes +1. All right, then I'm going to put this entire thing back into my transform. Transform dot local scale is equal to local scale is going to be equal to the scale. All right, the scale. And that's all it takes. So basically, I've inverted the scale here, and I've actually put it in place here. And I put the whole thing back into my transform node up here. All right, I'm going to save this. File, save, bam. Now when I hit play, as long as I've done everything correctly, I can run forward, and I can run backwards, and we're going to face the opposite direction. All right? Boom, boom, boom. The good thing about facing the opposite direction is my actual weapons flip too. So I don't have to worry about, my character always has a good profile. We can always see the weapon nicely. All right? So there we go, everybody. That is our running back and forth. Our character is already moving along. We got a game going here. I'm quite excited. That was a pretty long episode, guys. I hope you enjoyed it. If you did, let me know down in the comments with a thumbs up. If you didn't, let me know with a thumbs down. If I'm going too quickly or I'm not showing things properly, let me know with a thumbs down. But make sure you tell me why and what I did wrong, okay? And that way I can correct it. Thumbs up, thumbs down, comments down below. And if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.